For lecture 30, number 2, they're asking for which one is the strongest base in the following reactions. So for letter A, it's HClO4 plus H2O for reaction to ClO4 minus plus H3O positive. So first, let's find out which ones are the acids and bases. Since this has an H in the front, this would have to be the acid. So the H2O will have to be the base in this reaction. And since this one has gained a hydrogen, this would be the conjugate acid, and this should be the conjugate base. So now the first thing you have to look for is if it's a forward reaction, which it is. So that means the H2O would have to be the strongest base based on the forward reaction. And also the fact, since it's the strongest one, there is no reverse reaction, so these can't come back to this. So this proves that H2O is the strongest strongest base in the reaction. And for letter B, the equation is HNO3 plus H2O forward reaction NO3 minus plus H3O positive. So again, find which ones are the acids and bases. Since this one has an H in front, this will have to be the acid, so this is the base, and again, conjugate acid and conjugate base. So now, knowing that we have all this, we have to again look at the reaction, and we see that's a forward reaction. And since this is the only base in the reaction side, H2O is the strongest base, based on the forward reaction symbol and the fact that it's too strong for it to be in equilibrium, so it stays as the strongest base in the reaction.
See, we have 2H2O that goes to OH negative plus H3O. We know that the water can be acid or basic, so it allows us to have conjugate acid. This can be a conjugate base, and this can be the conjugate acid, because the water can make both of them. So we know that OH is negative. It's fully negative because of the negative that's right here, and the H3O is fully positive. So we know that because water can be acid or basic, it's considered partly negative. So we know that the OH negative is a stronger base because only H2O can be partly negative.
For 2D, the equation they give us is HF plus H2O equals H3O plus F. We know that the H3O is the conjugate acid because the water receives an extra hydrogen. That means this is the base, and this would be the acid, leading us to know that the fluorine would be the conjugate base. Because it is equilibrium, we have to decide between these two bases which one is stronger. And according to our knowledge, we know that the stronger electronegativity, the stronger the base. And because fluorine is on the right-hand corner of the periodic table, we know that it has a stronger electronegativity, leading us to believe that fluorine is the stronger base.